So again, I'm a graduate student from Yonsei University at South Korea. And this presentation is about indoor defect region identification. Let's start with this question. How many defects can you find on this image? Actually, there are 35 cracks on this image. As you can see, this is not an easy task, not only for a human inspector, but also for an advanced object detection algorithm because of the small size of the target object. So this is the traditional grid-based approach that can find small object on the omnidirectional image. The input images is split by the spherical grid, and the grid cell is inspected by the training detectors. Maybe this one will be fine because most of the training data set looks like this because they are acquired in the close distance. But in case of this, it spanned multiple patches. It may be misclassified. And this one is still too small to be detected. Maybe adjusting the grid size and overlapping some adjacent patches could be a possible solution, but this is not the only problem. As you can see in this example, there are various backgrounds on the indoor environment, so it can be misclassified as a defect, which can lead a large number of false positive cases. So my research question was, how can we identify region of defects? So we considered subtracting images could be one possible solution. Let's say we have a clean and perfect version of the indoor space images. Then the remaining part after subtraction could be considered as a possible region of defect. So we acquired this image from the BIM model and leveraging the photorealistically rendering tools. But the subtracting two images to compare is not an easy task. So we proposed a couple of pre-processing method and the post-processing method to extract the selective normal field of view patches, but expecting to reduce the number of patches to be inspected and to extract the regions that are possibly defect. So I will briefly introduce each process one by one. To secure the clean image, we create the S-design model with Revit, and we used Revit Enscape to generate photorealistic rendering image. Since the light condition could be different between the on-site image and the rendered image, the color matching operation has to be conducted. And to adjust the geometric distortion, we control the three parameters to rotate one image to minimize the mean average value of subtracted pixel. And then after subtraction, we conduct the intensity-aware kinetic detection to emphasize on remaining parts. And based on the remaining part, we created and merged the bounding box based on these 6 resolution-aware parameters. With this sort of process, there are 262 bounding boxes can be generated on this test image. To extract the normal field of view, based on the coordination of the bounding box and its size, the normal field of view patches can be extracted that is fitted on the target object. The extracted patches will be inspected by these 2 defect detectors. One is the vision transformer classifier, and another one is deep lab width plus symmetric segmenter. So to validate our proposed method, the 2 different region extraction method will be compared based on the inference least performance and result from the 2 different defect detectors. And to secure the generalizability, we consider the 4 different resolution from the 3 different off-the-shelf omnidirectional cameras. And for the target space, there were 35 number of artificially implanted rear cracks based on the distributed by its crack size and based on the crack position. And here are the experimental results. As you can see, the number of patches is successfully decreased by leading to the increased number of F1 score, which means we can neglect the false positive cases successfully. And I will make a discussion based on the highest resolution cases. So this is the overall number of detected cracks. It is 19 over the 35 cracks. As you can see, still the small size and the cracks on the complex background cannot be easily detected in either way, but still we have a performance increase in the F1 score. So this is the extracted result from the traditional method and the proposed method. As you can see, the proposed method can centralize the defect features. So some defect that cannot be detected from the traditional method can be detected with the proposed method because the visual features very resemble to the training correct data set. And by investigating the whole extracted features, we concluded that the extracted patches consist of not only crack features, but also the discrepancies with the S design conditions. So still we have some limitations because we only studied the limited defects type, which is a crack, and the cracks on confusing background or too small cracks cannot be detected in any cases. And the registration part took too much processing time. It took around 10 minutes in our case, in the highest resolution case. So we are going to make a future research based on, we're going to extend the defect types and determine the proper detectors and training methods for indoor defects. And we are going to replace the registration part with by applicating SLAM algorithm for instantaneous registration. And that's all for my presentation. Thank you for your attention. And I will take questions if you have any.
Yeah. Any questions?